That sounds good.
Good morning, everyone, and welcome to the weekly BBSim Brigade call. We have two topics in the agenda for today. Chip is going to give us a presentation about the project he's working on that is called ONU mock. And I personally think it's a very, very interesting project, and there is overlap with what we are doing with BBSim, so maybe we can find a common path here. And then, time permitting, after the presentation, I wanted to just take a look at JIRA and see what is going on there. So, Chip, I'm going to make you presenter. Does that work for you?
Okay. Yeah, that'll be fine.
Okay.
Okay. Can you see my screen?
No.
Okay. I might need to. Nope. Yeah, I'm on my Mac. Let's see. Can you see it now?
Nope. Nope.
Okay. Yeah, I'm wondering because Mac, it popped up a request to show my screen. Let me join from my Windows system real quick. That might be a better one because I've presented from it before. So
okay, yeah, no problem.
Off the screen. Come on. Sorry about that. Okay. Yeah, I've logged in on my Windows machine, so let me.
So let me make you presenter.
Yeah.
On this one. Okay.
Okay. Yeah, I'll make sure.
Okay, we can see your screen now.
Okay, let me get the. I'm trying to see if I can get the right things. Sorry, I had that's the first time I had share my screen off the Macintosh. And I had everything set up on the other screen to be easy. Yeah, what I did is, I guess about a year and a half ago, I guess do a real quick back story. About a year and a half or 2 years ago, I started learning Go. And so, I took some classes and everything, and I decided about a year ago to, outside of just normal small applications I was writing, to do something a little bit more ambitious. And I was working on the Open OMCI project at my former employer, and decided there was no OMCI packet drivers for Go Packet. So I went ahead and decided to go ahead and write a Go Packet library. So that's this OMCI, and I think Mateo's looked at it, and a few other people have. So I started off as two different things. First, I wanted to write an ONU mock to basically mock the entire pond so that we could simulate ONUs, and that was the ONU mock project, which is this discussion is about. But that required me to go back and write a Go Packet library for OMCI. So I just want to let everyone know that that's out there. It's a Apache 2, and I use it in the OMCI mock. So feel free to make use of that if you want to in the BBSim project, and use the ONU mock as an example, because there's lots of examples for it. Or and what we'll actually do is do the ONU mock, which is the main presentation. So in previous work that I've done, to do scale testing at the former employer I was at, we virtualized a lot of our firmware so that we could run it on large HP servers, big multi-blade servers, and try to scale some of the provisioning up to hundreds of thousands of customers. So, and that proved pretty fruitful. And so that's what I decided to try to do on this. So instead of going through to virtualize take the ONU Volta device adapter and virtualize that, I decided to go ahead and look at virtualizing, using that virtualized OLT and tie that into something that makes it look like the PON exists. So basically what you do is, instead of going out and actually going out to your FPGA or to the BAL to have it actually control the PLOM and the OMCI channel, just change those to gRPC calls and basically have it call out to this mock to do that. Is that sort of clear of what I'm talking about, or? Hello?
Yeah, I think.
Okay.
Sorry, I was looking for the unmute button. Yeah, it's clear.
Okay. I had problems on my my Mac laptop. I want to make sure I didn't break things on my Windows machine as well. So basically, what the ONU mock is basically it's a service that runs. It's a Go application that runs a service that has a very simple startup routine that you can pass in information to it and specify the number of PONs to simulate and the number of ONUs. And it will come up and basically start to enable those PONs and those ONUs, based off of either doing it sequentially after some pauses, turning things on one at a time, or basically all of a sudden turn the entire PON on. So if you had a PON, say, with 16 PONs out there with 32 ONUs each, you could have it sequentially add those, so you can see a growing number of ONUs starting to come up and be discovered, or you could have it pretty much do a big bang. So that's what the capability is. So basically, this is the service start. It basically comes in an initial, and you can have it auto start, which is what I'm typically running as a test. So after about 10 seconds, it's pretty much ready. Has each of the PONs and each of the ONUs are running as separate Go routines, so to make use of the multi-threaded capabilities within Golang. And then once it goes from started to enable, it will enable the PON. So an OLT will do gRPC request. In the case, I guess, if you wanted to implement it with BBSim, I would suggest either calling it from BBSim, or maybe take the OpenOLT agent that runs over on the Edge core. And if you actually virtualize that, then you could actually run the traditional OpenOLT device adapter and have it point towards that virtualized OLT agent.
Yeah, so that's basically what BBSim is, because it exposes exactly the same gRPC interface that the OpenOLT agent on the box does.
Yeah.
So it can basically be a man in between the ONU mock and the OpenOLT adapter.
Okay. Yeah. So basically, just wherever it wants to do, the agent wants to go out and do a PLOM request, it would basically do a gRPC called, basically it does a discovery request over gRPC to the ONU mock, and it'll be returned any ONUs that happen to be activated at that time. So you would do the normal process there. And then anytime it wants to do the OMCI proxy request on behalf of an ONU device adapter, it would just basically do a gRPC call on the OMCI channel. So, so pretty much the OMCI, it's fairly obvious what we want to do is OMCI request response. So this is what you would perform. Basically the ONU device adapter would do a proxy request to the BBSim, and when instead of doing actual function call out, on the PON, it would do a gRPC request and get a response back from the mock. And then of course, prior to, periodically, I guess the BBSim, the agent, would be doing periodic clone requests to do a discovery, and would be provided back an ONU discovery information. And at that time, it could also, then it would send out an activate request. And that activate request will start up the ONUs from a known fixed state. And currently I have the ONU mock will do the full nib sync and nib reset capabilities that you find in most device adapters. It also supports capability discovery through the OMCI ME, as well as for time synchronization, so you can set time up to begin doing performance monitoring intervals. And then with regards to service provisioning, my first goal is to get just basic high-speed internet service capabilities. So that includes pretty much supporting all the MEs, the bridge MEs, the bridge port configuration MEs, unis, and ANI, all those associated capabilities for high-speed internet service. And currently I'm working on the TCONT. So I have just a little bit more to go, probably about, I would guess probably about 1 or 2 weeks worth of good work to get high-speed internet service capability working.
Question is the future of this ONU mock basically handling only OMCI messages? You're not planning to add any kind of packet support, like for example EPOL or DHCP or IGMP or even a ping kind of.
I currently, Well, I currently have provisions for that. So within the, as the OMCI MEs come over and are instantiated inside the mock, it does do some basic constraint checks. And there is for each of the ONUs, MEs that are in the data path, there is a packet handler that can receive a go packet. And currently I have not implemented anything related to that, but the idea of what I was going to do is at the uni, PPPT Ethernet uni interface, and also over on the PON side on the ANI, to be able to have those as packet injection and extraction points, so that as a packet is received at the uni, it will actually be handed off to the bridge port that it's associated with and go through the proper tagging capabilities. But none of that work has been done right now. My first focus was to try to get up as many ONUs as possible, because the MIB synchronization and MIB auditing are a fair amount of overhead. And then the second goal is to be able to create the 15-minute intervals on many of the interfaces. So, to do 15-minute performance intervals, because that's also a very time-consuming process as you start to scale up a LAN. Scale up the PON, I'm sorry. So that was the first goal. So packet handling is important, because we need to have that that capability to do a higher level service. But I would probably suggest that if you wanted to initially used this to make use of the Volt add subscribers command to basically fake the EA poll service so you can actually go through the extra steps to do the subscriber provisioning of their flows.
Cool. Yeah, that makes a lot of sense, and I think, like as you said, just preparing the plumbing so people can inject and extract packets. That's great. So then everyone can send any kind of packets that he wants.
Yeah. Ideally, it'd be nice to be able to actually simulate RGs as well and make those RGs perhaps even be Go packet interfaces that snoop off the net.
Okay, and do you have an example of a configuration for the ONU PON, for the ONU MOX?
Yeah, there's a couple configurations. So one is actually for the ONU mock itself. So this is an example. This is the example one that currently what I'm doing. I'm actually over in the utility subdirectory. There's a small application. Let me go to that real quick. There's a small application called ONU mock olttest.go, and that basically simulates a lot of the steps that ONU device adapter or an OLT would perform with respect to starting up the mid-state machine. So you can look at this application to see basically what the an OLT device adapter or BBSim would probably want to be able to do, how to tie it in. Of course, you don't really need to implement those state machines because that's the purpose of the ONU device adapter. So I just want to point out that that is there, and it's a nice, really quick way, so you can test some of the capabilities without doing a lot of virtualization. But in the configuration, it's basically a YAML file. So you can define a set of vendors, and what these are is I was able to tie into the OMCI proxy application and actually record request and response times for a lot of the MEs. So within these device models, which I'll show you in a little bit, those actually give some maximum minimum times to actually do round trip OMCI requests, because as you start to virtualize these ONUs, if you're on a very, very high speed blade where it can run really quickly, it would actually do a response in microseconds, when as a real OLT would take typically between 4 and 100 milliseconds to actually do some of the OMCI request. So these basically model an alpha and a TNW ONU, and I'll probably eventually add Iskratel and a few others. So these are actually sort of models for specific ONUs. And also many of these things can be overridden on the startup command line. So auto start basically gives you the capability. So once it comes up, pause a brief amount of time and then send an enable out to the service to start running. You can control the number of CPUs that Go routines can use. So that's the max CPU count. PON count provides a maximum number of ONUs, PONs that would be created. Max ONUs per PON can go up. I actually wouldn't go much over 128. I've typically done 16 PONs and 16 ONUs, but on a desktop machine that can really tax your CPUs. And then the REST port is not currently implemented, but eventually I'd like to support a northbound interface so that you can individually enable or disable ponds or do fault injection. And then there's a section where you basically describe how a pond actually comes up. So initially, in this case, a pond is enabled automatically after 10 seconds. And then it'll sequentially turn one pond on after another. So you could basically set this delay to 0, and it would basically turn all the ponds on at once if you wanted to change your settings that way. Then there's a default ONU mix that you're allowed to do. So you can specify the percentage of ONU vendors that are on each pond. So this is a default. And then if you wanted to go through and change it so that a specific pond only has certain vendors, you can further tune the ponds on the capabilities here. So that describes the pond, and then of course the ONU configuration. In this one it'll sequentially enable every ONU that you're trying to bring up. So this pond 0 will bring up four ONUs. So one ONU will show up once every 10 seconds on that pond. So that gives you some ways to turn everything on or turn everything off at one time. So that's the basic configuration of the ONU mock program. And then for vendors, there are models. So this database, this is basically what an alpha initial MIB database looks like. So it'll actually come up to make it look like an alpha. And this is the model of that alpha. So it provides some various information. Eventually, I'd like to be able to support multiple different versions of firmware, but I think getting just one model working for all firmwares for specific vendors is pretty significant. And then in this file, it tells you what the message types the alpha supports. And it actually supports test results, get current data, and I don't know if it supports set table, but I don't really support test. I haven't actually supported this yet in the OMCI. Then it provides all the MEs that the alpha supports, so that should you do a request for an ME that it does not support, it can give you the proper error message back. And then here's the information that I retrieved from actually doing various, tests against an alpha. So actually bringing up some service. So the minimum response time was 2 milliseconds, but some creates took as long as 231. So it'll try to average some of the create times for you.
So just to make sure I understood correctly, are those time used by the OpenU mock to set timeouts between the different requests to have a more realistic scenario?
Yeah. What it does is when the ONU mock, when the service receives the OMCI request, so if it receives a MIB upload request, then it'll snapshot the time that MIB upload request is, and then pass the start time over to the model, and the model will schedule its response time to be an average, an average time between, in this case, it looked like I only did one MIB upload, so it'll actually wait 25 milliseconds before it gives you the response that the BIB upload, it's snapshotted the database, so that you get a little bit more response times. And then the MIB upload, it'll typically takes around 67 milliseconds round trip for the proxy message to be received. So it'll actually try to delay it some so it doesn't respond too quickly.
Okay, thank you very much, Chip. Is there something else you wanted to present?
No, just I guess if you know my repository, it's under on GitHub under C Bowling ONU mock. So you know, feel free to pull it down. Like I said, I'm currently working on the TCONT. So since I'm working on this as a personal project, not necessarily a work project with Tibet, even though we might actually be using it at Tibet in the future, I hope. I should have the high-speed internet service done by the end of the year, so that you should be able to pretty much bring up, you know, tie it into an actual device adapter and bring things up and simulate a pond.
Yeah, so this looks very, very interesting because we are so I used a little bit the OMCI library in BBSim because we have a tool to scale test BBSim that basically emulates ONOS and Volta to send just more to send faster responses and stress BBSim, and they use the OMCI library in there. In BBSim, we are still using a very small library that I think Shad created a while ago. That was basically a TCP dump of the OMCI messages that were coming out of an alpha, and we are just sending those messages. So having this kind of support for OMCI configuration is something that looks very, very interesting to me, and it wouldn't make sense to go and rewrite this from scratch since you have already done all this amazing work. So I think I think I'll probably spend some time and see how hard it is for me to wrap my head around it and figure out how to plumb it into BBSim. If there is a need to plumb it on in BBSim, and eventually we'll be able to use it and possibly support you on the new features you need to add.
Okay, yeah, and I went ahead and finally updated the README file to reflect a little bit more of what I'm actually trying to do. So the current feature set here, and so because I really see besides stress testing a OLT device adapter, this will help stress test spawning up, because you actually, you know, if you have a ONU device adapter and you tie the OLT into this mock, then you'll run a ONU device adapter as is. It thinks it's actually talking to a real system. So that can get the BBSim out of the business of trying to pretend ONUs are coming up, because you could actually use this to make it look like ONUs are being activated and have the core start the device adapters for you for the ONUs.
Yep. Yeah. Well.
And yeah. And like I said,
like when Volta will do enable call through gRPC to BBSim or whatever is there, then BBSim can transform that call and call into the ONU mock saying, okay, just go and enable the PON, and then it will start proxying up the ONU discovery messages. Volta will send down enable ONUs, and so BBSim will basically become a proxy.
Yeah, and so this is probably what you would want to do. This is the main tie-in to create an endpoint for OMCI, and it goes through and creates, you know, discovery response, and basically it goes out. It does Plum request for discovery, and as it sees a message, a response, it goes out and activates the ONUs. So this is sort of what you would probably tie into BBSim for the Plum side for discovery and activation, and then this is your OMCI proxy handler would just basically be these two function calls for request and response.
Yeah, and would you see this, considering that BBSim is written in Go, would you see BBSim calling the ONU mock over gRPC, or importing ONU mock as a library and calling it directly in the same process?
I would probably initially, what I would suggest doing, and when I want, eventually is once I get it running, I plan on placing this in a container. So I would call it over gRPC, because right now the ONU mocks a single OLT. So if you wanted to have BBSim come up and run multiple OLTs, then you would need to spawn a separate one. So I would suggest having it separate, because it separates the concerns a little bit.
Okay, yeah, that makes sense. Yeah, so far BBSim is trying to emulate a single OLT2, and if you want multiple OLTs, you just spin up multiple BBSims. So
yeah, so it could do either way. But if you did it, if you used basically the gRPC as a separation, then you don't have to worry if we keep the gRPC API the same. You don't have to worry about changes in the mock. You can just inherit those as more work gets done on it.
Yep, that makes sense.
Okay.
Oh, okay.
And over, I guess, in the document subdirectory, basically here's some of the capabilities that I plan on doing in the initial release. So being able to bring unis up and down, or to do power fail simulation. So those are things that I have planned to be able to do fault injection into the system. But the first goal is just sheer scalability of ONU showing up.
Okay, thank you very much for the presentation, Chip. Does anyone have other questions? Okay, I'll take that as a no.
Okay.
Thanks, Chip.
Oh, sure. And if there are any questions, just fire me an email and I'll look for them.
Sounds good. I'll probably send you some emails soon.
Okay. In my Tivit email, I check that all the time. My Gmail, I usually only check that once every other day or so.
Okay.
Okay.
Thanks.
Okay, thanks.
Thanks.
So let's see, how can I get the presenter right back? Okay. So since we have some more time, I wanted to go through JIRA just to see where we're standing. I know we are investigating on Volta 1977 that is running the sanity test twice, does not succeed. We have been seeing that sometimes it succeeds, sometimes it doesn't. The first investigation we have done seems to point to some packets that are dropped in Volta. At the moment, it's kind of hard to track where these packets are being dropped, so I'm working on a patch in Volta to make it simpler to track the same the same packet through the various components to have a better indication of where we're missing these pieces. SIBA 824 is actually still assigned to me, but is mostly Zdravko that is working on the reboot command. Do you want to quickly speak about it, Zdravko? Oh, I think he's not online anymore. Okay, so
yes, I think I also not here.
yeah, I think I saw him earlier, but maybe he had some other commitment. So, you know, it's kind of late in Germany. Anyway, there is an email thread on the BBSim Brigade with a proposal to address that issue. So if you have any concern about it, please take a look. The scale test for BBSim and BBR, it's always in progress, meaning that we are trying to improve the current situation, but we have a pipeline job that is running on Jenkins and is collecting information. So far is fairly stable, up to 256 ONUs. That sometimes fails though, because there are some issues. Sorry?
I'm sorry to interrupt your talk. I have one question about the graph that you showed in the last page. So is that the y-axis of the, this graph means runtime second, right?
Yeah.
So 3.75 second. Okay, I got it. It is amazing.
It's it
seems
when the issue we are seeing. So there are two sides of it. As Chip was saying, he created, he got the snapshot of the real timing of a new, while in BBSim we are just firing messages as fast as we can, and that may not necessarily be the best thing to do to emulate the real environment. And we're seeing some issues when we scale past 256 with the DHCP packets. Initially, I thought it was because the DHCP server we're running in BBSim wasn't able to keep up. So I tried with different DHCP servers, but they all stop around the same number of packets, that is around 1,500 packets. So I'm investigating other possibilities.
I understand.
Yeah, now I'm suspecting that the listeners that we put on the interface on the BBSim side are actually missing some packets, but I still have to verify this. We tried. There is a patch in Gerrit that basically sends out the DSP packets in batches instead of all together. With that patch, we were able to scale BBSim up to 960 ONUs in around 40 seconds. When we tried to scale it to 1024, I'm seeing some OMCI issues that I suspect are related to the canned library that we're using. But also that one is still to be investigated.
Okay, thank you for sharing your information.
Sure. Then, Gilles, I think you're working on the testing side. Do you want to speak a little bit about it?
So I've completed 2 test cases so far with 16 ONUs. So that's the pre-provisioning and the discovery. So those are just about to be merged. I'm going to have my own Jenkins job to run that. So that's going to be set up soon. So that's about it.
Yeah, that's great. Thanks.
Mm-hmm.
And we have another item in progress from Zdravko that he rightfully pointed out that not all the operators are using or interested in EPOL DHCP. So we want to make them optional while running while running the scale test. They are already optional when you're running BBSim. They actually won't start the authentication process, and the DHCP process won't start automatically when you run BBSim unless you specify a -out and a -DHCP flag when you start the process. But this particular topic regards the scale testing tool BBR to support this the same feature. And the last thing in progress that we have, I think it's William. I don't know if William is online. I see a William. I'm not sure is William working.
Yeah, can you hear me?
Yep.
Yeah, it's in progress.
Okay.
Yeah, so I'm putting in so for someone who knows, I'm putting a Jenkins job for testing the scale as probably nightly or something. I haven't done this kind of thing before, so I'm trying to have a basic one in that should set up a cluster with some help from Zach, and hopefully I'll have that running soon so I can start adding the actual scale tests. But
Okay. Thanks, William.
Sure.
So there is nothing else on the agenda. So unless anyone has something else we want to talk about, we can get 15 minutes back.
Hi, Matteo. This is regarding IGMP.
Yep.
Yeah. Matteo, can we create a new JIRA item for that? I guess we don't have any item so far.
For IGMP?
Yeah.
Okay. Yeah, I'll make sure to create one so we can track it.
Or I'll create myself.
Okay. Yeah. If you want to create it, just when you create it, if you can make sure to add BBSim as a component so that it will show up in this dashboard.
Yeah, sure. Okay.
Okay.
Yeah, and we have submitted another patch set, and we have fixed address few of the comments we got from you on last patch.
Yeah, I've seen the notification for the patch. I haven't looked at the patch yet, but I'm going to look at it right after the meeting.
Yeah. Okay. Arjun, are you there?
Matteo, Arjun here. Are you able to hear?
I can hear you.
Hello?
I can hear you, but not very well.
Okay. Matteo, give me 1 minute. Are you able to hear me now?
Yes.
Okay. Matteo, while I was implementing the BBCTL commands, and while testing it was observed that the command was terminated. I got an error message saying that the command was terminated with exit code 371. So I tried to debug the issue and found out that the control flow was not going from the onu.go command file to onushandler.go. Can you look into the code that we have submitted if, just to confirm that if we have done the correct way or not?
Yeah, I'll absolutely review the patch today, and I'll make some comment and I'll send you some feedback.
Okay, mate. Thank you.
Matthew, one more thing actually. The Go packet library, the igmp.go file, it's not having the serialization. I mean, there is an interface available in that library, serializable layers. All the other packets such as DHCP, EAP, EAPOL, all of these packets are using that implementation for serialization.
That is
but
good.
in IGMP, it's not. Yeah, that's not available actually. So can we go ahead and start making changes in our code, or do we need to make changes in that library itself?
So I think as a first version, we can just make the changes in our code. But once we have it working, it would be nice to send a pull request to that library so other people can benefit from it.
Okay. Okay. So I'll implement this. Yeah.
Yeah. To implement.
I'll implement serializable layers. Mm-hmm.
Yeah. To implement it, whatever is the most comfortable for you, go ahead with that, and then we can always make a pull request to the upstream library anytime.
Okay.
Okay, guys. Thank you, everyone. Have a good Friday or a good weekend, depending on your time zone, and talk to you soon.
Thank you, Matthew.
Yeah, thanks.
Thank you.
Bye, everyone.